So we need to talk about similarities and differences between Biot Savart law and Coulomb's law. So Coulomb's law is going to be force F is equal to K Q1 Q2 by R square, right? K can be expanded as 1 by 4 pi epsilon naught. But when it comes to electric field, remember we would take one of the Q over here and then you would write it as electric field is equal to 1 by 4 pi epsilon naught Q1 by R square. Right? You still have the R, you are just bringing the Q on this side, right? Force by charge will give you electric field, right? So we have seen this many times. So people who are not there for the first chapter, we will try to do it in the Sunday. Okay, so if you are not able to follow what this means, just for now take it down. So Biot Savart law is here we say dB is equal to mu naught by 4 pi I dl sin theta by r square. Okay. So basically we are going to compare this and tell the similarities and differences. So what can you say about the similarity? What looks similar? Both are inverse square law, yeah. So that's a good point. So first you can say both are inverse square law. Similarity is both are inverse square law. Instead of material dependent, you can say medium dependent, right? Is this medium, right? When you are talking about a conductor, you would call it as material. If you are talking about a medium where you are keeping the entire setup, then it would be medium, like vacuum medium, air medium, right? Water medium. So it is medium dependent, yeah, you can write that. Both are constants, but it will be different. So you can say both have some medium dependent constants. So you can say epsilon naught or mu naught. Okay. If you don't understand my handwriting, let me know. Or if you are not able to see anything in the back. Size? Okay. I told you have to come to the front bench. Okay, then let's talk about the differences. So here I can say, right, Q is charge. Charge is scalar or vector? Scalar. So Q is scalar. So that is the source. So the charge is what is producing this electric field, right? Here IDL. So here we are going to say IDL. So what it means is this term together. So dl, what did we say? It is a vector, meaning what is the length this way. So whether if I take a dl this way, it will have a different direction. If I take a dl this way, it will have a different direction. Are you following what I am saying? So idl is actually a vector. So idl is a vector. So that is the source here. So this is the source here. This is the source here. This is the source here. Here, do you have any theta here? No. What about that? You have a theta. So that means this does not depend on the direction or angle, right? So what it means is, look at this. So if I had Q1 here, and then if I had Q2 here, or let's say if I had Q2 here, right? So if it is at same distance, if this is R and this is also R, right? The force will be same, right? Are you following what I am saying? So the angle does not matter, right? Whereas here, the angle matters. So whether it is R is here or here. So if I take another point here, so maybe I will draw it. Are you following this? So if the R is same, right? Everywhere here, it will be having the same force. So theta does not matter. Only R determines the value. Here I am going to say, if I have a DL here, right? And if I take a point P here, and if I take a same distance point P here, right? So in this case, if you calculate the dB, it is not going to be same. It is going to be different. Okay. So take it down here. You would say. So that's what the sine theta is. So P1 and P2 will have different dB values as theta matters. So here theta does not matter, there it matters. Okay. Instead of writing it here, I am going to erase this and write it here, okay, so that everyone can see it properly. So third one, this is most important one. So if I take Q1 and Q2 here, right? So this is Q1, this is Q2. So where do you think the forces are acting? Which direction is it acting? Is the force of repulsion, is it acting this way, or is it acting this way, or is it acting this way? The third one, how do you call that? Linear? Sometimes you will understand it, but if you don't know how to express it, you will not be able to write it properly in the exam. So this you would call it as the line joining the two charges. So you don't have to show this. Direction of force and electric field are given by line joining the two charges. Okay, this you already know from your first and second chapters or the first chapter. Here what did we say? We said dl cross r. So look at my thumb. It said it's going into the paper, right? So the direction is completely different. Okay, so because we are talking about the differences here, so here we are talking about the difference about the direction. So here it is given by the line joining the two charges. Here it is given by dl cross r, which is perpendicular to both. So we say direction of D, meaning the magnetic field, right? Magnetic field is perpendicular to dl and r vector. Okay, so these are the important differences. Similarities, we already talked about it, right? Both are inverse square law, both are material dependent concepts.